Let's write biconditional statements in symbolic form and English. Well, if this doesn't sound like fun, I don't know what does. First, what is a biconditional statement? Well, bi means two, so we have two statements, true both ways. Now, what does this mean? Well, if we have two statements, let's just say we have statement P, statement Q. So we often say, if P, then Q. We'll assume this is true. And if we say, if Q, then P, let's assume this is true. So true both ways, meaning if P, then Q, and if Q, then P. If these are both true, then we can write a biconditional in symbols by using a double arrow, so arrows on both ends. And this means P if and only if Q. So this is using words, this is using symbols, okay? So that's the idea of what we're doing, but you have to check the truth value both ways before you just write a biconditional, because not all things are true both ways. So consider the following two statements. If possible, write a biconditional statement in both words and symbols. So statement P, N is a non-repeating, non-terminating decimal. Statement Q, N is an irrational number. So first things first, let's check if P, then Q. Well, what does that mean? That means if N is a non-repeating, non-terminating decimal, then N is an irrational number. Is that true? Well, by definition, a non-repeating, non-terminating decimal is an irrational number. So yes, this is true. Okay, so now let's check if Q, then P. So this means if N is an irrational number, then N is a non-repeating, non-terminating decimal. Also true. So because it is true both ways, we can write this as a biconditional. So in symbols, we have the two-sided. Right? Okay, so this is the symbolic form. Okay, so now in words, first of all, we're going to keep the idea of if and only if, right? So in words, we would say a number n is a non-repeating, non-terminating decimal if and only if n is an irrational number, right? And so this is in words, using the if and only if. That shows the biconditional piece.